All right, this is Mr. C for Math 1111 9 o'clock Zoom meeting. Did any of y'all show up with any questions? Did y'all get a chance to view the assignments for this week?
Yes, I actually have a question about exercise 59 on section 1.7.
Okay.
I don't know where any of the answer, like I don't even know how they got the answer. Because
Well, I think if you read the assignment, we didn't assign 59.
oh, I know, but like when you read through like it explaining how to do the math, I guess, it
Uh-huh.
asks do certain like exercises that
Right,
are kind of like the example, just like with
right.
different numbers. So you can, I guess, just like try it out and it gives you the answer too. So you
Uh-huh.
can got it right. But I have no idea like how they got the answer for
Let me
the
put your mind at ease. I'm trying at the beginning here to keep this as simple as I can, believe it or not. So in this section, I'm only assigning in 1.7 the first two sections, which are linear inequalities and quadratic inequalities. 59 is an example of fraction inequalities. I just think it throws too much at you all at once right now. We're going to see them in chapter 3.
Okay.
And when we do, it'll be a simple extension of what we've done now. But I'm not going to mess with them right now. I just think it throws too much on people.
All right, thank you.
Uh-huh. Does anybody want to see my Reader's Digest version of what is going on here? This is where the course starts to get technical. You have to know your interval notation. You have to be able to graph stuff on number lines with open and closed circles. And there's 4 cases of interval notation. Does anybody want that spiel? Not getting much response. That's what I did in the 12 o'clock Zoom meeting. I started from scratch trying to explain because they want you to solve these, graph these, and write an interval notation, and it gets pretty darn technical. Does anybody want me to go over an overview of the basics?
Yes, please.
Did I hear a yes, please there? It was,
Yes.
it was very faint.
Yes.
Did I hear a
Can you
yes?
hear me?
Barely, barely. Did I get a yes?
Sorry. Can you hear me better now? Yes.
Okay. So the way it works, in fact, I'll just do the very first homework problem here, and then I'll expand on it to show you all the other cases. So this is from 1.7. Page 148. And the very first one's number 11. Now it says solve the 3 magic words. There's 3 magic words. Solve, graph, and this graph is one-dimensional, not two, not an XY axis kind of graph. Strictly one-dimensional number line. And write in interval notation. Okay, so problem 11 is 5x less than or equal to 6. You treat these pretty much like they've got a straight equals, and this is a pretty simple one. You would simply divide both sides by the 5. 5's cancel, and you wind up with x less than or equal to 6/5. This is the solve when you get your x by itself. The graph, again, it's in one dimensional. Draw a line, put a tick, put the number, which happens to be 6/5 or 1/5. And you're going to stick a closed circle on this one because there's an or equal to. This means 6/5 works. 6/5 by itself works. 6/5 is less than or equal to 6/5. So with an or equal to, you have closed circles. No or equal to, open circles. So if the or equal to had not been there, I'd used an open. So I want all numbers less than this. Less than means I'm to the left. If it had been a greater, I'd been to the right. Now, interval notation can be copied off the graph. It's copied off the graph. I need a left side and a right side. Since this goes forever, the left side would be a negative infinity. And I simply copy the negative infinity and the 6/5. And I put a parentheses here and a bracket on this one. Bracket because it's or equal to. And it's basically saying all numbers from negative infinity up to and including the 6/5 work and solve this equation. I don't know if y'all got that low battery. Better plug in. We won't finish. Okay. So let me show you all the cases of the interval notation because the solving, it works pretty much like you're used to. X's to the left, numbers to the right. Once you get it solved, it's a matter of reading. If you're less than a number, you're on the left. You're greater than, you're on the left, right. And if you got the or equal to, it's closed circle, bracket, no or equal to, it's open. And then you can copy the interval notation off. But the interval notation, it gets technical. Let me go to the next page so I got plenty of room. So there's 4 cases of interval notation. I'll just use numbers. Like case 1, 3 less than x less than 5. This says all numbers between 3 and 5, but you can't use 3 and 5. So you're not including 3 or 5. All right. I like to draw the number line. You'd have a 3, you'd have a 5, and you've got open circles because there's no or equal to's. You're shading in between them. That's where your X is. That's the graph. The interval notation copies down the left end and the right end with a comma. Use parentheses. Parentheses with no or equal to. Equal to. This does not mean in this section X is 3, Y is 5, even though it looks absolutely identical. In this section and a couple of sections, this just simply means a one-dimensional interval, numbers between 3 and 5, but not including 3 or 5. All right, second case, let's include 3, not 5. That would mean 3 less than or equal to x less than 5. number line, 3 closed circle, 5 open, again shaded between them. That's the graph. Interval notation, 3 comma 5, 5 with the parentheses because it's just like this, but the 3 with a closed circle got a bracket. Closed circle or equal to. You got an or equal to. All right, before I give you the last 2 cases, I guess we should pause. This ring any sort of bell? Have y'all seen anything like this before?
Yeah, I have.
Okay.
Not really.
Not really. Okay.
Part of it, but part of it isn't clicking.
Okay. It's just the system to learn. Parentheses go with closed circles. Brackets go with, I'm sorry, I said it back. My fault. Parentheses go with open circles. Brackets go with closed circles. Brackets, closed circles, and have or equal to. Open circles, parentheses, no or equal to. After we do 3 or 4, you'll kind of get used to it. Let me show you the other 2 cases. Case 3, include 5, not 3. That would be 3 less than x less than or equal to 5. The graph, 3, 5, closed here with the or equal to, open here, shade between them. You have 3 comma 5, bracket there, parentheses there. So I've switched the bracket and parentheses from case 2. That's the interval notation. This is the graph. And finally, case 4, include both. 3 and 5. Less than or equal to x, less than or equal to 5. I'll just go over here to include it. 3, closed, closed, shade between. 3 comma 5 with brackets on both. So you've got to read what you have and then use the system, and the answers in the back of the book for the interval notation will be written in this system. Any questions before I pick another example problem? Oh, there's one other detail. If you divide by a negative number, you must switch the inequality. Let me show you this. Case 1, just straight, a 2x equals 6. You divide by 2, equals 3, and you're done. They never make you do anything more. If you wanted a graph, one line, put a 3, put a closed circle. There's no real interval notation for this. Only one number works. 2 times 3 is 6. All right. Case 2, make it 2x less than 6. You divide by 2, just like you're used to. X is less than 3. And this works straightforward. Put a 3, you'd have an open circle, shading that way. Any number less than 3, like 2 times 1 is less than 6, 2 times negative, or less than 6, no problem. You want the interval notation, stick a left side on it. The interval notation, negative infinity to 3 with parentheses. Here's the problem, or the trick. If it's 2x less than, negative 2x less than 6, you would divide by -2, strictly a less than, sorry about that. You'd have an x and a -3. But the correct solve is x greater than -3. Switch this when you divide by a negative number. Now, is this obvious? Everybody remember this, or is this completely new and someone wants an explanation of why you do that?
I would like an explanation, please.
Explanation. Oh my goodness. Do my job. Got it. All right. Well, let's do it the wrong way and don't. It's a consequence of the sign rules. But to show it, I really have to do it the wrong way and show why the wrong way doesn't work. And the wrong way is not to switch. So if I go -2x less than 6, I divide by the -2 and keep it x less than -3. Graph it out on the number line. You'd have an open circle. This way, this is the wrong way. This would say numbers on this side are like -4. Well, check -4. This means you'd plug in -2 times -4 less than 6. Well, when you do, you get a +8 less than 6. Doesn't work. Numbers on this side will plug back in and will not check. Correct way is to make it x greater than -3. In other words, you're on the wrong side of -3 here. Graph it, -3, open circle. The correct is to be on this side. So for example, try 0. Check 0. You'd have -2 times 0 less than 6, and you wind up with 0 less than 6, which is correct. Any number this side of -3 will work in the sign rules and work. So the general rule is, if you divide by a negative number, you switch this inequality. And you do the same thing if it's an or equal to. It doesn't matter about the or equal to. You do the same thing if it was an or equal to. Does that help?
Yeah, it helps a bit.
Okay. Let me try another one before we jump to the next section, or not next section, but next group of problems. Let's try problem 23. This is 1.7, page 148, problem 23. Four minus 3x less than or equal to a negative 1 plus 8x. Four minus 3x less than or equal to, and then this negative would distribute, -1 minus 8x. All right, in this section, that's why they call them linear. They're all first power. It's a matter of x's to the left, numbers to the right. The order you do this doesn't matter. I mess with my x's first. I'm going to add the 8x, add the 8x. That would be 4 plus 5x less than or equal to -1. Subtract the 4, subtract the 4. 5x is less than or equal to -5. Divide by the 5. And x is less than or equal to -1. And the 5 is positive, no switch. Positive, no switch. So this is my solve. My graph, -1, got the or equal to closed circle. Less than would be this side. I like to write in the other end because now my interval notation is negative infinity, comma, negative 1, closed circle, says bracket. And it just simply means any number all the way to negative infinity through negative 1 and including negative 1, I could be plugged up here and would be true. This side would come up less than or equal to that side. So this is our answer in interval notation. Anybody want to ask anything about that? Any questions? The next group of problems starts at problem 33. Are we ready to charge into those? It's kind of a completely different animal.
Sure.
Sure, okay. One 1.7, page 148. Start with problem 33. X plus 2, x minus 3 less than 0. Once again, solve, graph, write in interval notation. Okay. This works off what you would do if you had a straight equals. Compare to x plus 2, x minus 3 equals 0. Would everybody know to write x equals negative 2, x equals 3? And you're done. Would everybody know to do that? You switch the signs on the factoring.
Yes, sir.
Okay. Well, when you do inequalities, less than or greater than, you get infinite answers. You get intervals. Your answers are intervals. There are infinite numbers in any interval. No way you can write them down. Infinite number of numbers. In any interval. So we've got to must identify the intervals. We must identify the intervals. All right, so I'm going to start over. Solve x plus 2, x minus 3 less than 0. You still write that x equals negative 2 and x equals 3. Oops, frozen here. Okay, maybe it'll come back. Darn internet connection. Okay, here we are. Just like up here. You do the same thing just like you were up here. You write these numbers down. These are not the answers. Can you tell why? See, if I have negative 2 plus 2, negative 2 minus 3, I get 0 times negative 5 less than 0. 0 is not less than 0. Same thing with 3. This would make this 0. 0 times this is 0. Not less than 0. But what I do is I go to graph, and I put these in order on a number line. -2, and I put 3. That divides it into 1, 2, 3 intervals that I've got to identify, figure out which of these actually work. At the -2 and 3, I'm going to stick closed circles because there's no or equal to. If there was an or equal to, these numbers would actually be answers, but they're not the only answers. But with no or equal to, they're not answers. So what I've got to do, there's now 1, 2, 3 intervals that are possible for the answer. I've got to pick numbers inside each interval and test them. And this is where it gets kind of arbitrary. It does not matter what number you use. You can pick any number you want. This side of -2 would be like a -3. I'm going to write a test. So when I check x equals -3, or test it, I plug in, meaning I get -3 add 2, -3 minus 3. Is this less than 0? Now, I could figure out the numbers. This one's easy enough too. I don't really care about the exact number. I only care about signs. See, a -3 add 2 is a -1, so I just go write negative. And a -3 minus 3 is also negative. It's a -6, but I don't care about the 6. Is that less than 0? Well, when I multiply these, a negative times a negative is a positive. Less than 0. No. Positive numbers are greater than 0, not less than 0. Negative numbers are less than 0. So this entire interval does not work. Let me pause for station identification before I test the other two. Anybody want to ask about that? Not getting any response. Is that because this is so easy, it's like kindergarten? Or is that because it's, why did I sign up for this class?
I'm with you so far.
Are you? All right, well, you see there's 2 more intervals to check. I always like to use 0 because it's an easy number to check. So when I check or test x equals 0, I have 0 add 2, 0 minus 3, less than 0. 0 plus 2 is positive. 0 minus 3 is negative. A positive times a negative is a negative. Negative numbers are less than 0. Yes, this works. And I'll shade in between. Any number between -2 and 3 will work. If one works, they all work. Now I have to come to the other side of 3. I could pick 10, 10 million. I mean, usually like something, you know, pretty reasonable, close or whatever. So I'm going to, for my last, I'm going to test x equals 4. And I have 4 plus 2, 4 minus 3, less than 0. I hope it's obvious this isn't going to work. This is positive. This is positive. Positive times a positive is a positive. Positive numbers are not less than 0. No. This doesn't work. Any number to the right of 3 does not work. And now I can write my answer down. in interval notation right off the graph. Answer. I copied the -2, comma, the 3. Since they both have open circles, that signals parentheses. Any number between -2 and 3, but not including -2 and 3, can be plugged up into the original and will work. So the answers are here in this interval. Now, I know that's a lot of writing. I tried to go through it really slow and write down, explain for anybody, coming along watching this later. After you get used to this, you can shorten this up pretty good. You can almost check in your head, check the numbers and the intervals almost in your head. Anybody want to see, we're at 30 minutes. Anybody want to see another one just to try to nail this down?
Yes, please.
Oh, goodness. Okay. Why don't we try 37? (1.7), page 148. Solve, graph, interval notation, minus 3x, minus 18, and it's less than or equal to 0. They haven't factored this one for you. When they do these, they're going to give you the factoring pattern. If there's one with a number, you can use the quadratic formula to determine your two numbers. You don't technically have to factor those, even though they do factor. Y'all know how to factor on this pattern. Two numbers that multiply to -18, add to -3. Can you tell they'd be x minus 6 and x add 3? -6 times 3 is your -18, and -6 add 3 is your -3 in the middle. This gives you x equals 6 and x equals -3. These actually are answers because of the or equal to. If I plug in -3, I get 0. 0 is less than or equal to 0, one condition or the other. Only one condition has to work, and the or equal to condition works for it to be true. But they're not the only answers. So this is not the solve step. The solve step actually on these comes at the end when you write your answer down. The graph step, again, you put these in number order, so the -3 would go first, 6 would go second. Closed circles. Because of the or equal to, which indicates that both numbers actually work. But once again, does this interval work, that interval work, or the one on the end work here above 6? I'm dying to know. Literally, the suspense is killing me. So we'll try, -4. So we'll test -4. Again, you might be able to do it in your head. You can plug in -4, that's negative times negative is a positive. It doesn't work. But I'll write it down just for clarity. -4 minus 6, -4 add 3. This is negative. That's -1, so that's negative. Negative times negative is a positive. No, not less than or equal to 0. No. Is that going too fast? Not getting much response. Is that too fast, or everybody following that?
I'm still following.
Still following. Okay. We can try 0 in the middle again. Test 0. 0 minus 6. 0 add 3. Hopefully you can tell right away this what does work. Negative. This is positive. A negative times a positive is a negative, less than or equal to 0. Yes. We try 7. Test equals 7. 7 minus 6. 7 add 3. Hopefully you can tell it doesn't work. Positive there, positive there. That means you get a positive, less than or equal to 0. No. Only numbers between -3 and 6, including -3 and 6, will plug in this and be less than or equal to 0. Answer, and this is the solve step, -3 to 6. And this one will use brackets because you've got the closed circles up here.
Just a quick question.
Sure.
So if the like, let's just pretend that the 7 did work. You put like an infinity sign when you do the interval notation.
That's right.
Okay.
Yeah, let's pretend, in fact, all I've got to do is switch this to a greater than, and it would have switched this interval. I can tell you that I've done a million of these. This wouldn't have worked, but the 2 outer ends would have. I'll just give you a quick example. So, in other words, the graph, say it looked like this. Here's your -3 closed, here's your 6 closed, but the middle didn't work, and these did. See, then your interval notation would have been -infinity, -3, bracket. They take a U in between them, bracket 6, comma, infinity. Does that help?
Yes, that helps. Thank you.
Okay. Yeah, you'll find on these quadratics are like parabolas, there's 2 cases. Either the middle one will work or the 2 outer ones will work. That can help, once you learn that system, that can help shorten things up as well. Again, I'm going to skip start at 55. You got this fraction inequalities. I think that's too much to throw at people. I think this is the limit of at least what I found, the limit of people's technical thing. And we are going to get to that section in chapter 3. So I'm not going to cover it now. At the 12 o'clock meeting, I went on and did some stuff to introduce 1-8. Y'all have the patience for that, or it's pretty late at night, or y'all at y'all's limit?
Sure.
You want to see anything from 1-8?
Yes, please.
Oh my goodness. Okay. Well, in 1-8, they give you absolute value inequalities. So this is 1.8. Value equations. Let me do a really simple one, and then we'll try one out of the book. Solve equals 4. Okay, first of all, I might have to remind you about what the straight bars mean. Straight bars, they're called absolute value. If I put, say, a 4 between them, and they said simplify this, the answer is 4. If I stick a -4 between the bars, the answer is 4. The answer is the number between the bars. The number between the bars here is 4. The number between the bars here is also 4. In other words, it does nothing to positives, but it turns negatives to positive. Does this ring a bell? Does everybody remember this?
Yes.
Okay. Well, then these are the two answers on this one then. You would, number one, set your x equal 4, and the absolute value of 4 would equal 4. But number two, you would set your x equal to negative 4, and these are your answers. Absolute value of negative 4 is also equal to 4. So you don't undo this. A lot of times you want, like if I had x squared equals 4, I take square root. That undoes a square. Square root of x squared equals 4. You have to remember to put plus or minus 2. You get a similar thing here with the plus and minus, but there's no operation that undoes these bars. You just have to remember what its definition is and to bring in both cases. All right, let's try page 153, number 5. Solve absolute value of 5x equals 20. So case 1, set, see the 5x is acting like your x up here. You set whatever's between the bars equals 20. Most people get that. You do whatever you have to do to solve. In this case, just divide by 5, and your x is 4. And you can see the check. Absolute value of 5 times 4 equals 20. Sure enough, the absolute value of 20 equals 20. But you can't forget this other case. Case 2, set the 5x between the bars equal to negative 20. Still divide by 5, and x would equal negative 4. And you can see the check. You'd have absolute value of 5 times the negative 4. Inside the bar equals equals 20 up here. I'm sorry. You're checking the original. Yeah, it's negative inside the bars, but the bars turn it positive and it checks. Now you do not always wind up with a positive number and it's negative. I'm just starting really simple where that's happening. Let me show you that. Try another one. Try 13. Page 153. Solve absolute value 2x minus 3 equals 11. All right. Case 1, set your 2x minus 3 equal to 11. That's the easy case, like say everybody get. You just set whatever is inside equal to this number and solve it. In this case, add 3. 2x equals 14. Divide by 2, and your x comes up 7. You can almost see the check in your head, but I'll write it out. 2 times 7 minus 3. 14 minus 3 is 11 equals 11. Absolute value of 11 equals 11. Okay, but case 2, set 2x minus 3 equal to negative 11. Add 3. 2x would equal negative 8. Divide by 2. Your x equals negative 4. So you see one answer is 7. That gives you the positive 11 inside the bars equal to 11. A negative 4 gives you a negative 11 inside the bars. I'll show you. Check. 2 times negative 4 subtract 3 equals 11. Negative 8 minus 3, that's negative 11 inside the bars equals 11, and sure enough, this checks. So this is a case of two completely different numbers that are absolutely correct. 7 and negative 4. Does that ring any sort of bell, or does anybody want to ask any questions about that?
I'm with you. I understand.
All right. There's one more group of problems, and that's when you bring in an inequality. But I don't know, have we opened up your heads and poured in enough today? Or have you got enough brains to, tonight, I'm about done myself, this is late. Have you got the patience for another little group here in 1-8, or have we shown you enough for tonight? The 12 o'clock people, they'd had all they could stand.
It's up to you. I'm good either way.
Good either way.
Same here.
Okay, well, why don't we, just to be in line with the other video, why don't we go ahead and call it here?
That's fine.
So probably giving you enough to absorb, and then we can finish the rest of it in the Zoom meetings on Thursday.
Sounds good.
Okay, anybody have any questions or comments before we end the meeting then? No, is everybody good?
I'm good. Thank you.
The instructions for this week on the assignments were very good?
Yes, sir.
Oh, I guess one question.
Yes, go ahead.
The test, is it going to be like it was the same setup as the quizzes, you said?
That is correct.
Okay, so you're going to post it on, or what day are you posting it?
I'm going to post it on Friday in D2L.
Okay, and we
Under
just
the test button, it'll say test 1.
Okay.
Yes, some problems will be correct, some problems will be incorrect. You will answer true or false on the Google form that will be right next to the test.
Okay, all right, thank you.
The only difference between the test and the quiz is that the test covers the whole chapter, whereas the quiz just covers the material for that week. So the test is wider breadth. I did mail out the practice test. I don't know if y'all have checked your email since about 7 p.m. or so, but I did mail out a practice test with key. Did anybody get that?
Yes, sir.
Okay. All those problems are correct, at least as far as I know. So that's for your study and not for a grade.
Okay, and I guess my last question is, I assume the test we can only submit it once, right?
That is correct, yes.
Okay, thank you.
Yeah, I said that in the instructions. So yeah, work them real careful. See if I did them right, in which case you'd put down true, the problem is correct. Think you spot where I screwed it up, put down false, because the problem would not be correct. Any other questions? All right, I appreciate y'all coming out this late at night, and we'll look for you hopefully again at either Zoom meeting on Thursday, 12 p.m. and 9 p.m. Thank you very much for coming out, and we'll end the meeting.
Thank you. Have a good night.
Yeah, thank you.